at the top of page 574, here are our steps for solving a general solution question. So it could be that they say find the general solution. It could be they say the domain is theta belongs to all real numbers. And it could be that they don't say the domain at all. And if nothing is said, you have to assume it means everything. So what did we do in that tan question? We solved it like normal from 0 to 2 pi. And then after you got your answers from 0 to 2 pi, you just add 2k pi, where k is an integer, to each of your answers. So I'd like you to put an X through example number 1. And instead, we're going to write this example. Yeah. Let me know when you're done. So we're going to write this example instead. 7 sine theta plus 1 equals 0. And now it's a general solution instead of a regular solution. This would be a calculator one. So according to our new steps that we just wrote down, we would solve it like normal from 0 to 2 pi. So I would get sine by itself, do sine inverse of positive 1/7 to get my reference angle. And this is an example of a bad choice of numbers, but it's kind of fascinating because, yeah, like sine inverse of 1/7 is 0.143, and 1/7 is 0.1428, which rounds to 0.143. So they're very similar. Then find your answers between 0 and 2 pi like normal. So it would be in quadrants 3 and quadrants 4. And the only thing new is you now take both of your answers and add 2k pi. Yes?
If you do it like this with like elegant version, don't you just have to find one of the numbers?
Elegant will only work for tan though, because in sine, if we draw a reference angle in quadrant 3 and reference angle in quadrant 4, it's not a nice halfway around anymore. So that's why I said most of us won't use the elegant way, because the elegant way only works for tan, but it won't work for sine or cos. Because only tan happens like positives 1 and 3, so it works out perfectly that they're across from each other, and negatives 2 and 4. Okay, ready for example 2? Same thing. It's a review of chapter 6. The only difference is it says find the general solution. So your job is to get that answer without just copying it down. So in this question, it doesn't give a domain, so that would mean you assume it's everything. tan squared theta plus 3 tan minus 7. If you tried to factor this, this would be an easy one to factor, because if I went to factor it, it would have to be tan theta and tan theta, and the only way to get 7 would be 7 and 1. Although if you check your outside and inside, there's no way with an outside of 7 and inside of 1 to get 3. And so factoring does not work. So what does it mean when you can't factor? You have to use a quadratic formula. It's on your formula sheet. On your formula sheet, it's x equals, in this case, it would be tan theta equals negative b plus or minus b squared minus 4, a is 1, c is negative 7, over 2a and so we simplify this, negative 3 plus or minus the square root of 28 plus 9, 37 over 2, which leaves us with two answers, negative 3 plus square root of 37 over 2, or tan of theta is equal to negative 3 minus the square root of 37 over 2. I can scroll up. Is that enough?
Is it 9 squared?
It was a 3.
Oh, right, okay.
Now, in order to figure out what quadrant these things are, because it's not necessarily obvious that the first one is positive and the second one is negative. You have to do a little bit of mental math. So sometimes in these cases, you go to your calculator, you type in negative 3 plus the square root of 37 divided by 2, get 1.54, and then the same thing with the minus sign. And get negative 4.54. So this one you know is going to be in quadrants 1 and 3. And this one you know it's going to be in quadrants 2 and 4. We need to find our reference angles. I'm going to split it here. Our reference angle for this one by doing tan inverse of that value, 0.995. So theta would be quadrant 1, 0.995, and quadrant 3, pi plus that answer, 4.137. So we find our reference angle, then use our cast rule, quadrant 1 and quadrant 3, to get our angles. We need to find our reference angle here as well. Okay? Some calculator tricks. The reference angle is always tan inverse of the positive value. So if I go up and take this answer from before, it's already negative. How do I change it to be positive? I could go back and delete the negative. That would be one option. Or you could multiply it by a negative 1. That would change it to positive. So my reference angle is 1.354. And then my actual angle, negative, now it'll be in quadrant 2 and quadrant 4. Since I need to use that twice, I'm going to store it as x. So quadrant 2, pi minus my reference angle, 1.788. And in quadrant 4, 2 pi minus my reference angle, 4.929. those are your answers between 0 and 2 pi. This was a general solution question, so the last thing we need to do in a general solution is theta is equal to. Write them all. If you like to have them in numerical order, you can. Then you have to go plus 2k pi on each of them. And this is one you could have done more elegant because it is 10, but like I said, most likely we'll just rewrite them all and write plus 2k pi for each answer that we get. All right, questions for practice are 5, 6, and 9. I know that 5 and 6 say just to solve between 0 and 2 pi. You can change those to general solution just to practice.